All right, here's part 2 of our quadratic applications lesson. We have this third section of our notes is titled projectile motion, and we have this formula here that we're going to use. So unlike the last two sections where we had to come up with our own equation, on this one we have been given an equation. And right above that equation, it explains what each piece represents. So we see here that the height in feet is this h variable right here, of an object shot upwards into the air with an initial velocity of v sub 0. So that's this v with a subscript of 0 after t seconds is given by the following formula. And you'll see t is in two places. One is here and one is here. And then we have this problem, number 5. A firework is shot upwards with an initial velocity of 130 feet per second. How many seconds will it take to reach a height of 260 feet, round to the nearest tenth? So we want to start with our given information and figure out where that gets plugged in. And then we'll figure out what it's asking us to find, and that will stay a variable. So we have that the initial velocity is 130. So this is going to go in for v sub 0. We're being asked how long will it take to reach a height of 260 feet. That's my h. And then right here it says how many seconds will it take. So that's our time. That's what we're looking for. So that's going to stay a variable. So I'm just going to plug in those things. And now we need to solve for t. So what I'm going to do is move everything on the right over here. And that's because you have to change their signs to do that, which is going to make this, once it's over on the left, it's going to make it a positive 16. And then I can go forward with my math. I can try factoring and so forth. And we always want a positive coefficient there. So I'm going to add 16 squared minus 130t to both sides of my equation. And then here's what I have next. 16t squared minus 130t plus 260 equals 0. And so now that I'm equal to 0, I can try factoring or another method. One thing I noticed here is that these are all even numbers, and the smaller I can make them, the easier my future math in the problem is going to be. So I'm going to take a second here and just divide 2 out of everything, even the right side. And that's going to give me 8t squared minus 65t plus 130 equals 0. Now what you might try to do next is slide and divide or factor using the cross method. And I'm just going to cut this a little bit short for you and tell you that's not going to work. We had a problem in the previous section where factoring didn't work, and so what we did after that was use quadratic formula, and that is what would happen here. So in order to use quadratic formula, you first had to identify your a, b, and c values. So my a value is the 8, b is negative 6, and c is 130. So I'm going to plug that into my formula. Now in your foldable, where we took notes on the quadratic formula, it says x equals negative b plus or minus blah, blah, blah. But in this case, we're not solving for x, we're solving for t. So I'm going to use t instead. T equals a negative b. Oh, I wrote 6 here, but it's negative, it's 65. So negative 65 plus or minus the square root of b squared minus 4 times a times c, all over 2 times a, which is 8. Now, in the previous video for this lesson and in the quadratic formula video, I talk about taking this math inside the radical, popping it out off to the side, and being sure you're following your order of operations correctly. And then bring it back into the quadratic formula, put it inside the radical, and go forward. I'm going to skip that for this video just to keep it shorter, and I'm just going to tell you what that answer is. So in the front right here, we have a negative makes a positive. So I have positive 65 plus or minus the square root of 65 all over 2 times 8, which is 16. Now this represents two different versions of my answer. It's a positive radical version and a negative radical version. So I'm going to split those up and then talk about them. So I have 65 plus radical 65 over 16, and then I have 65 minus radical 65 over 16. And again, I'm going to save us some time and just tell you what those answers are. The positive radical version gives me 4.6 seconds, and the negative one gives me 3.6 seconds. Now the question was in the original problem, how many seconds will it take to reach a height of 260? Now I have two answers. In our previous quadratic formula problem, we had a positive and negative answer, and we disregarded the negative because that problem was about length and width, and you're not going to have a negative length and width. But here I have two answers that look like they could both be it. Neither one of them are negative, so I can't just automatically disqualify one of them. So what's really happening here is this. A lot of times when we see height in a problem like this, we assume that it's saying that that's the maximum height that it reaches. So if I just draw a diagram here, whatever we've launched goes up and then comes down. And there's nothing telling me that this is my 260 foot height that this projectile is reaching. So since I can't assume that, here's what I can do. If this is my 260 feet mark, then it makes sense that I would have these two times, because as the firework goes up, it reaches 260 here, and then it reaches it again over here. So it hits 260 twice. So what these two answers are representing is both of those spots. It takes 3.6 seconds to hit it the first time, and then 4.6 seconds to hit it the second. So my answer is 3.6 seconds. And then you pause your video, try the last problem in the packet, problem 6, and then check it with the PDF in your Google Classroom.